So far, we've been talking about melting and boiling and liquids and solids, but now we're going to talk about gases. Gases exert pressure because the gas molecules collide with the surface. And we measure pressure in atmospheres, abbreviated ATM, and don't so many students look at that and think atom, but it means atmosphere. And 1 atmosphere is equal to 760 millimeters of mercury. You see that unit, for instance, in blood pressure. A torr is exactly the same thing as millimeters of mercury. And this is also 14.7 pounds per square inch, which is the English unit. And pascals is another unit of pressure, which we won't use, but it's you can see that 1 atmosphere is 101,000 pascals, or 101 kilopascals. All the things that the variables that affect pressure are temperature, numbers of molecules, and how big a container that's holding the gas. If you have a high temperature, the pressure is high. If you have lots of molecules, the pressure is high. If you have a small container, the pressure is high, and that's all because you will have more collisions. We have gas laws that govern the behavior of gases. For instance, if you double the pressure on a gas, it will half the volume. And we get a mathematical relationship to this that we call a gas law. This one's called Boyle's law. The initial pressure times the initial volume is equal to the final pressure times the final volume. And this holds true whenever temperature is held steady. Charles's law relates volume and temperature. If you double the temperature, the volume will double. Of course, this is if you hold pressure constant. We can write a mathematical relationship that initial volume over initial temperature is equal to final volume over final temperature. We have Gay-Lussac's law. Here, this relates pressure and temperature. If you double the pressure, the pressure doubles if you keep the volume the same. We write it as initial pressure over final initial temperature is equal to final pressure over final temperature. But memorizing all those 3 gas laws is kind of a nuisance, and people get confused with them. It's better just to use one equation right here. This is called the combined gas law. And what happens is if you keep any of these conditions constant, it drops out. So for instance, if you keep temperature constant, pressure 1 times volume 1 equals pressure 2 times volume 2. That was Boyle's law. So it just combines all of those gas laws into one, and you only need to use one. We're going to be doing word problems, and word problems are easy if you follow a method that helps you sort through the information. First, take each number and set it equal to a variable. Write it as an equal statement underneath the problem. Then you write the equation that applies. Here we're doing gas laws, so it's going to be P1 times V1 over T1 equals P2 times V2 over T2. Identify the variable that answers the question. This is going to be, the question will say, and what is the final pressure, or something like that. So circle it. Then solve the equation for that variable, meaning that you say, okay, I rearrange the equation until I get that variable equal, all by itself, equal to something else. Last of all, put the numbers into the equation and then into your calculator. Remember, all the numbers must have units. The units will help you think through the problems, because if the units don't work out, you have done something wrong. Here's an example. A balloon with a volume of 4.5 liters of helium at sea level is released. The pressure goes from 748 to 557 torr at 2,500 meters altitude. What is the new volume? Okay, let's go through each number. 4.5 liters, that's your initial volume. 748 torr is your initial pressure. 2,500 meters, that's altitude. We don't need it. You have to use your head now. You always get extra information. Don't assume everything in the problem is something that you need. Then the final pressure is 557 torr. Look what it says. It says, what will be the volume? That's your new volume. So write down the question mathematically. V2 equals something. Now write the equation that applies. You see, we're going to be solving for V2. So I need to get rid of P2 and T2. How do I get rid of P2 and T2? Well, remember it says, assume that the temperature remains constant. So T1 and T2 cancel out. And this equation then holds. I have to solve for V2. I have to get rid of P2. It's multiplying times V2. So I divide both sides of the equation by P2. When I do, that cancels this P2 out and puts it in the denominator of the other side. Now that I've gotten my equation solved for, I put my numbers into the variables. 748 torr, 4.5 liters, 557 torr. Torrs cancel out and I get liters. That's a relief. If you look at your units and see that they work out to answer the question that's been asked, there's a good chance you did it correctly. You do your math and you get 6 liters. Go ahead and try this problem and a couple others, and we'll go through them. Okay, you have a balloon, and it's indoors at 27 degrees Celsius, a volume of 2. What will be its volume outdoors when the temperature is 23? These are the variables. T1 is equal to 27 degrees Celsius. V1 equals 2 liters. T2 equals negative 25 degrees Celsius. However, the gas laws do not work with Celsius, so you must convert them to Kelvin. Okay, now what we do is we write the equation that applies. What is held constant? Pressure. So I can rewrite it like this. Now I enter in, I'm rearranging the equation. Now I solve for my V2, and I do that by dividing or multiplying. Let's go back. I need to get V2 by itself, so I have to get rid of T2. T2 is dividing into V2, so I have to multiply both sides of the equation by T2. There we go. T2 now cancels out, and I get V2 equals V1 times T2 equals T1, like that. Okay, so now I plug in my variables. T2 is 275, V1 is 2 liters, and T1 is 300 Kelvin. I multiply through, and we get 1.8 liters. Go ahead and try this one. Okay, we take all the values and we set them equal to a variable. Notice we have volume, temperature, pressure, everything's varying. So this equation applies and we're not going to be able to toss out anything. All of them are changing. So the question asks what volume, so we solve for V2 by undoing what the other things are doing, and it simplifies down to V2 equals T2 P1 V1 over P2 T1. If you're having any trouble with your algebraic rearrangements, please come see me and I'll help you with it. No problem. Or go see a tutor or ask a friend to help. Okay, let's plug in our variables now. T2, P1, V1, P2, T1. Let's look and see what happens with the units. Kelvins cancel out. Torr cancels out. What's left? meters cubed. I do my math, and the volume that I get from this is 0.489 meters cubed.